Okay, welcome back to another video. In this demonstration, I'll be going through the PyTorch workflow, the fundamentals of it. Basically, the chart that we're going to be using our studies on is this chart. So first you have to convert data into tensors and build the model. However, before we begin, what I want to tell you is that if you have any doubts, any problems, any questions, project related, you can just come on Fiverr, link in description, and you can contact me. I'll be happy to help you with any problems or any tasks that you might have or any explanations. So just come, sign up, click the link, sign up, and then you can chat with me. So this is the chart, right? This is the workflow that we're going to be using to complete this Google Colab. I'll post this notebook in the description as well. So the first step is any data has to be converted into tensors. It could be emails, it could be random text, it could be audio. You have to convert it into tensors. Tensors are just multi-dimensional arrays. So you can have a scalar array, you can have a 2 by 2, you can have a 3 by 3 or 4 by 4, and etc. Yeah? After you convert these numbers into tensors, or you put them in tensors like this, so anything, spaghetti, spaghetti, emails, audios, it gets converted into tensors. Okay. Once they're in tensors, then you pass it through a model. The model basically learns using these tensors and it updates its parameters. Once the model's parameters are updated, the model can now predict and give you an output representation just like this. Okay. In this lab, what we'll do is I'll just go through some subheadings. Okay, brief understanding of how these things work. So first stage is data preparing and loading. So you're putting your data into tensors. The second step is to build the model. The architecture of the model has to be built, and we will go through the code, don't worry. Then you have to train the model. So first you come up with the architecture, then you build, then you train the model, sorry. And then once the model is trained, you make predictions with the model. So inference. If you're gonna be deploying this model to in your website or trying to integrate it with API, then you need to and save the model basically. You need to know how to save and load the model. And yeah, and then we'll put everything together and we'll do one exercise, and there are many more exercises down over here. Okay, so let's begin. Once again, I'll put the notebook in the description. So first you have to convert these things, any data into tensors. Okay, so for example, this is torch.arrange. This is basically a tensor. Okay, and we've given it a start value and an end value, and we've given step 0.02. Now it's going to create, basically it's going to create an array of size. Basically its dimension is like, dimension is 10 basically, because we have 10 steps here. Okay, and the linear model that we're making is y equals weight times x plus bias. Now the thing is, when you're predicting the parameters, you're usually not given the parameter values, because this is what the model is actually trying to predict. The model will take in the data, it will learn the patterns, it will update its parameters using loss function and stochastic gradient descent. Once the parameters are updated, then it will make a prediction. However, it's very important that in this case specifically, the parameters values are known. Okay, because I'm trying to explain it, so you need to know what we're trying to actually achieve here. So basically in this example, we're trying to approximate the weight to be 0.7 and bias to be 0.3. So the model is going to start with random tensors. So random values is going to learn, it's going to update its parameters, and the weight is going to go close to 0.7. It might be 0.6999. Bias will go close to 0.3, be 0.2999. Okay. Another very important concept is splitting your data. So whenever you're training a model, you have to do I mean, the best rule is do 80-20 split. So 80% is your training set and 20% is your test set. And you can basically do that with a simple function. So it's very simple. You just do indexing, you just use colons. And what we're going to do is the 80% of our data set will go to training and 20% will go to testing. So we're going to train the model and then we're going to test it on unseen data. Remember, the test set has to be unseen. The model cannot have exposure to the test set when it's training. If the model has exposure to the test set, then the whole model will be very bad because it won't generalize to unseen data. Remember, we're trying to train the model and then we're trying to make predictions, but those predictions are going to be on unseen data. So in real life, you're not going to get a training set. The model's already been trained. So what we need is unseen data. So we need to test it on unseen data. Okay, and over here it's pretty simple. Training set, validation set, and testing set. Training set just trains the model. Validation set is for hyperparameters. So anything like any learning rate, loss functions, all of these are hyperparameters. Basically, you set them before a hyperparameter is basically something that you set before training. So the validation set is set before training and it's used to tune the hyperparameters. And the testing set is obviously unseen data. We do it after all the training phase. So after training set validation set has been completed, then we do the testing set. Okay, so this is just splitting up. This part over here is just splitting up the data. It's very easy. Here we're just plotting the predictions. It's just showing you how it works. So the training data and the testing data. Okay, so this is just giving a representation of the data we're dealing with. The model we've built is a linear line. Okay, so now we're going to build the actual model, the architecture of the model. Okay, now relax because it looks confusing, but it's very easy. Just bear with me. The class, this is called object-oriented programming. When you see something called class, when you see something called super, when you see something called initialize, then it's referring to something called object-oriented programming. I hope you've done this course. If you haven't, then there's a good guide over here, Real Python Object-Oriented Programming in Python. This is some extracurricular activity. You can try it. However, if you are familiar with it, then we're good to go. So when you put nn.module, this is from the Torch library. So from the Torch library, you do import Torch as nn. Nn basically is the building block for all PyTorch models. So when you put nn.module inside class linear regression model, you're basically subclassing. So every function in nn.module will be available in this class. This is called inheritance. It's all of the things you learned in object-oriented like polymorphism, abstraction. This concept is called inheritance. Basically, it takes all the functions and it can be used in this class. We have two functions in this class. One's called def init, which basically means initialize, and we have def forward. Def init basically means you're initializing the parent class. So nn.module has a constructor. We have to initialize that constructor. So we need to put super.initialize. Okay, because remember, this linear regression model class is subclassing nn.module. So this linear regression model is a child class. The parent class is nn.module. So from the child class, we need to initialize the constructor of the parent class. Okay, that is why we use super.init. And then because this example is very straightforward, we have self.weights, self.bias. There's just two parameters. However, in reality, like with GPT models and many decoder, encoder, transformer based architectures, you have billions and billions of parameters. Okay, so writing self.weights for like a billion is not feasible at all. So what we're going to be doing is, this is just for understanding purposes, but know that there are tens and thousands of parameters. Okay, the second function is def